The seventh question that we have is a very important question. We've been given P vector, Q vector and R vector, which are three mutually perpendicular vectors of same magnitude. We have been given a vector x which satisfies this equation, and we need to find out what is the value of x vector, and we have been given four options. Now if you look at these terms carefully, these are symmetric in terms of P, Q and R. There is no biasness between either P, Q or R. Therefore the answer has to be symmetric with respect to P, Q and R. Therefore D option and A option are rejected. Therefore we have to choose between B and C. You can also apply objective approach to solve this question. Put the values of x vector, try with this and try with this, whichever you get the answer, that will be the answer. But better still, let us solve this question. We know that our answer can either be P plus Q plus R by 2 or P plus Q plus R by 3. This P is P vector. I am not writing the vector sign here. Now, if you look at these terms carefully, this is A cross B cross C. Therefore, this can be written as P vector dot B P vector into x vector minus Q vector minus of P vector dot x vector minus Q vector into P vector. Now this is the reduction of the first expression. Let us use the information which we have been given. We have been given that these three are three mutually perpendicular vectors. Therefore we can write P dot Q is equal to Q dot R is equal to R dot P is equal to 0. This is one information that we have. Another information that we have is that all these three have the same magnitude. Therefore P dot P is equal to Q dot Q is equal to R dot R is equal to A square, where A is the magnitude of the vectors P, Q and R. Now this is the information we have to solve this question. Now since both the other terms will also reduce like this, we can write this as summation of P square, P dot P is P square into x vector minus Q vector minus of summation of P dot x minus Q into P vector. Now summation of P square into x vector minus Q vector means summation of P square into x vector minus Q vector, P square into x vector minus Q vector plus Q square into x vector minus R vector plus R square into x vector minus P vector. It is the full expansion. Now we can write P square. We find that in each of the three terms we will have P square, Q square and R square. Now each of these terms is equal to A square. Therefore we can bring A square out common. And we have x vector minus Q vector, x vector minus P vector and x minus R vector as summation now. Therefore this will become A square into 3 times x vector minus P vector plus Q vector plus R vector minus of summation of P vector dot x vector minus Q vector. Let us expand this also. This becomes P dot x minus P dot Q minus P dot Q. P dot Q is 0. Similarly, we will have other terms Q dot R 0 and R dot P 0. Therefore, for all the three terms, that term can be cancelled. This becomes equal to P dot x into P vector. Now, the other terms will be, now look at this term carefully. We have already solved this term. We need to solve the summation of this term. This term is actually P dot x into P vector plus Q dot x into Q vector plus R dot x into R vector. So this is of the format alpha P vector plus beta Q vector plus gamma times R vector, gamma times R vector. Now looking at this, something should strike you, and that is, since this vector is a vector in 3 dimensions, it can be represented as a summation of these 3 vectors, because these 3 vectors are 3 mutually perpendicular vectors. Now any vector x vector can be represented as a summation of 3 mutually perpendicular vectors. Therefore we can write x vector is equal to alpha P vector plus beta Q vector plus gamma times R vector. For some values of alpha, beta and gamma, this will be true. Now let us find out those values of alpha, beta and gamma. Now this is very important. Let me write it over here. Let me write this statement above: a square into 3x vector minus p plus q plus r. These are all vectors minus summation of p dot x into p vector. Now, we have x vector is equal to alpha p vector plus beta q vector plus gamma r vector. We need to find out these values of alpha, beta and gamma. Let us take x vector dot p vector. This will be equal to alpha of p dot p, that is alpha p square, alpha times p square plus beta times q dot p is 0 and similarly r dot p will be 0. Therefore, we will get this as alpha p square. Similarly, we have terms of p dot x into p. Therefore, we can write p dot x as alpha p square. Let me write this as alpha times p square. P square is a square. Therefore, we write a square over here and we can take a square out common. Now, alpha times p vector, this summation becomes alpha times p vector plus beta times q vector plus gamma times r vector, that is equal to x vector, because we had assumed x vector to be equal to this. Therefore, this term becomes x vector. Therefore, we can now write a square times 3x vector minus p vector plus q vector plus r vector minus a square times x vector is equal to 0, because this quantity was given to be equal to 0. Therefore, on solving this, we get 2 times a square cancels. Therefore, we get 2 times x vector is equal to p vector plus q vector plus r vector. Therefore, we get the value of x vector to be equal to p vector plus q vector plus r vector by 2, and therefore this is our final answer. So this was a very important question from which we learned how to manipulate equations given in x, and to realize the fact that whenever we have a vector, it can be represented as a summation of 3 mutually perpendicular vectors with suitable coefficients.